I'm going to be talking about copies, in particular a very special kind of copy that I'll call a proxy. So these are not copies of the sort that you might make in an editor, where a copy is kind of a duplicate of something, but rather it's a copy of an object that's part of the user interface that's going to be used for interacting with or referencing that particular object that is a copy of. And the idea is it can have different properties in its object. It might be positioned differently, oriented differently, scaled differently at a different level of detail. It might have different amounts of filtering. And also, it may be manipulated very differently than its object that it's a copy of for different purposes. So this is a very abstract description, obviously. I want to give you some more specific, more concrete examples. And I'll start with one of the oldest kinds of proxies, something known as a world in miniature. This is work due to Richard Stokely and colleagues at Randy Pausch's lab back some 30 years ago, published in the CHI 1995 conference. And the idea there is that the world in miniature was a copy of part of or all of the virtual environment, scaled smaller as in miniature, or on the other hand, might also be scaled to be bigger. You can think of this as being a generalization of the idea of a mini-map in games, most of which, up to this point, were things that were placed at a very specific location in your typically single screen in which you were playing the game, and they were useful for figuring out, as the name map implies, where you and other things were in the environment. And so the idea with a world in miniature is it's much more general. It might give you a very different view, very much like a regular map does. In this case, you're seeing a world in miniature in the center of this simple 30-year-old view from Stokely's work of the lab in which they were working. The world in miniature is in the center. It can actually be held in one of the user's hand, brought closer to be able to see it better, further away, twisted around, for example, to see different aspects of the world. It might have different levels of detail. It can be used to select things and manipulate things. So you can select and manipulate it in that world in miniature or in the full-scale world. So because now it is scaled down, you can see things that you can't see in the current position and orientation you are in the full-scale world. You can see them in that world in miniature. And as well, because it's a separate copy, it might not be synchronized. So you might be able to do something in the world in miniature that you don't get to see yet in the full-scale world until you say, okay, I want to commit to doing that. Now, in addition to selecting and manipulating, you might be able to select and manipulate some representation of yourself in the camera. And so here, again, from this older work, you're seeing a representation. I've basically zoomed in on part of the world in miniature. I'm going to change the highlighting over there a little bit so you can see there's a representation of the user's location as an avatar. And the idea is you might manipulate that avatar pose to travel, or you might show, let's say, the view frustum of the avatar. And in their work, they also looked at how when you traveled, instead of literally traveling in the full-scale world, you might literally fly your view, might dolly your view into the world in miniature and then take over the world in miniature, which now completely surrounds you. So really, really useful technique that many, many systems are using now, but maybe not as many as I think should. So let me switch to a very different kind of proxy. And this is demonstrated in some work that we did a while ago, where the copies were copies of physical objects. A proxy is going to be a twin, think of it as a digital twin of its physical object and its full 6 degree of freedom pose, which means that the proxy or set of proxies can show the state of the physical world. Now, if you have a remote person or a local person who's trying to show you how to do something, and you don't want them touching the actual physical world, or they can't because they're remote, the idea here is you might be able to have them create a version of that copy, of that proxy, that they can control, but instead of allowing them to control the actual proxy, which means it ends up not being in sync with the physical world, instead you can make it so that when they try to grab the proxy, instead they spawn another copy of it that they actually can control and use to demonstrate in action. So let me give you an example of that in some work that we showed off at SIGGRAPH in 2017. Here we have a local technician in AR. There's a task domain that consists of a chassis with a bunch of gears and axles. And then we have a remote SME, or subject matter expert, and their job is to tell that local technician, show that local technician what they want to do, what they should be doing. And they're going to do this by creating these replicas. So here's the task domain. Again, chassis, a bunch of axles, a bunch of gears. Our technician knows how to put gears on axles. They just don't know which gear, which axle, in which order to do it. Our remote SME is working with a headset. In this case, our SME is wearing a Meta 2, different Meta than the current Meta, a Meta from a long time ago, now defunct. And this is an optical see-through display, and they are basically, this is our technician, not our expert. Our technician is physically doing the task, okay? And they're going to be seeing overlaid stuff shown by the expert. And now our expert in this case was wearing an Oculus. Back then it was Oculus, not Meta Rift. And they're seeing this digital twin, this set of proxies representing the task, and they're going to create these replicas to show how to do stuff. And so what they see here on the left, you're seeing a bunch of virtual proxies. On the right, they've tried to grab one of them, and now as they grab, they create this virtual replica that they can use to show, to demonstrate what they want to have the technician actually do. So what does this look like from the standpoint of the technician? So here we have our technician. They're seeing the chassis, seeing the axles, seeing the gears. These are all being tracked with 6 degrees of freedom. And so when they do anything, when they move anything, translate, rotate anything, it's going to show up that way in the world of that remote expert who can see the state of the world. And now the remote expert making these replicas is going to demonstrate to the technician what to do. So here we're seeing the technician's view. That is a replica being moved by the expert, and now our technician is following suit, positioning their gear, putting it in place, and then our expert's going to say, okay, now we want to take this other gear and move it on that axle, and now there's a little red rubber band line showing how to do it. And so this is the view basically that our technician, actually boots on the ground with the stuff that they're manipulating, is seeing. So what does our expert see? Again, this is entirely, at this point, these are only proxies, are exact copies in terms of position and orientation and geometry of the stuff that's in the physical world. And what they're going to do is they're going to reach out to grab one of them, but we're not going to let them actually grab it. Instead, they're making a replica. They're showing what to do. And at the same time, our technician is following suit and actually putting that physical gear in place, and you're seeing them manipulating the proxy. Again, the same thing happening over here. Pick up another one of the gears, and as they're putting it in place, even at the same time, our technician can actually be doing it as well. So you can have people in parallel manipulating stuff, although the physical stuff lives at only one place and is controllable only by the technician. There's no robotics to enable the remote person to actually do anything. So I think that's a really interesting and very useful thing we can do with these proxy copies, and in this case, a kind of proxy that we called a replica. Now, what I want to do is to show you one more technique, and this is one that is, I think, kind of the poster child for the idea of doing things by manually, with different hands doing different things in VR. It's a technique that was published by Jeff Pierce, also in Randy's group, back at the very tail end of last century. It was published as something called Voodoo Dolls some quarter of a century ago, and to avoid that problematic cultural reference, I'm going to refer to it as bimanual proxies. And in this work, each of the user's hands can manipulate a proxy of an object. If you select an object with a particular hand, you're going to create a proxy of it in that hand. And so an object that might be very far away, instantly now you have a proxy in your hand. You can look at it, bring it close to see it, wave it around, look at the other side if you can't normally see it that way, and because you're holding a copy of it, okay? And these copies are temporary. If you let go by unclutching if you're using bare hands, by letting go of a trigger button, let's say if you're using a controller, the proxy is going to disappear. So temporary proxies. If you have a proxy in only one hand in this technique, the only useful thing you can do with it, with only one hand, is you can look at the proxy, you can inspect it, you can see what it looks like, you can wave it around, you can show it to somebody else, you can demonstrate things. When you let go of it, it's gone, okay? You've had absolutely no effect on the world. Okay, so why is this useful? It gets useful when you have, besides this kind of inspection, when you have proxies in both hands. And one very interesting thing about that technique is they basically channeled work that was done by Yves Guillard, also towards the tail end of the 20th century, trying to explore different ways of bimanual interaction and pointing out that there's a number of different ways in which the hands work asymmetrically. Like, for example, the difference between skipping rope, where your hands are pretty much copying each other in sync, climbing a rope where they're alternating in phase, or playing an instrument, let's say like a guitar, where each hand is a very different thing. One on the neck, one is actually plucking the strings, okay? Many other instruments in which the two hands and any other tasks do very, very different things in cooperation with each other. So with proxies in both hands, this technique takes advantage of the fact that most people have a preferred or dominant hand, we'll call it the P hand, and the other one's going to be the non-preferred, non-dominant hand. So if you're a righty, your preferred hand is going to be your right hand. So when you are holding in both hands proxies, then the proxies do stuff. And the preferred hand proxy is going to control the 6th degree of freedom pose, the position and orientation of the actual object itself. The non-preferred hand proxy is going to be a reference frame for the preferred hand proxy. Its object in the full-scale world is not going to move. It's not going to change orientation, not going to change translation. It's just going to sit there. And so in this example, which gave the technique its name, we see the non-preferred hand is holding this little proxy of a toy soldier. It's at an angle over here, and yet the toy soldier is upright. And the preferred hand is holding a pin. And the idea is if you want to stick the pin in the soldier's back, instead of doing this, you can simply turn the soldier, stick it in, and in the full-scale world, the pin will look like it's rotating around the soldier. The soldier, again, the full soldier object stays still, okay? Because the transformation is being done in a relative way. Now, in the original technique, there was a lot of other stuff that I'm not going to mention. There was some automatic scaling, which worked sometimes, it didn't work in others, and some ways of spawning additional proxies based on their proximity to the one in the non-preferred hand, or the fact that they might be under the scene graph representation for the non-preferred hand. So, what I want to do now is to basically show you an example of this, and you're going to see some halos and arcs. This is from a user study that we were doing in which the yellow halos indicate something that's supposed to be done with a non-preferred hand. The red halos, something to be done with a preferred hand. In this case, you can see the halos around the controllers. This is for a person who's right-handed. And when you see an arc going from a proxy that will be spawned to the original object, that indicates that the hand, whose colored arc it is actually holding that proxy. And if they let go, you'll see the proxy disappear, and the arc disappears as well. So here we now see a proxy in the non-preferred hand. They let go of it, it disappeared. So then they pick it up again. It's a motherboard. That's where the RAM is supposed to be. When we have it in both hands, they jump, and now the RAM is getting put into the slot. When it turns blue, it means that it's in there. And when they let go of it, we're still holding the proxy in the left hand. And then when we let go of that, the proxy disappears because they're temporary. Okay? In that original technique, the proxies were all temporary. And what we were trying to investigate in the work that we did is the advantages of temporary versus permanent. Now, it turns out if you read the original paper, everything is temporary. If you actually look at Jeff Pierce's thesis, you'll see that in one paragraph, he suggests, hey, they could be permanent also, and here's some nice reasons you might want to make them permanent. And what we wanted to do in our work was to explore in more detail with a study the advantages and disadvantages of permanent versus temporary. So let me give you just a very quick overview. And so here you're seeing, again, two hands holding a motherboard and RAM. But you're seeing two more proxies. These are permanent. They're going to stick around when we're done. And one of them is a proxy at the upper left for a graphics card. And the idea is that graphics card proxy essentially is going to be very hard to create originally, because that graphics card, whose little halo you can see behind the chair and even perhaps behind the table, is occluded. So if you want to go and grab it in this situation, you're going to have to somehow get rid of the chair, move the chair, maybe even move the table, move yourself in order to be able to grab it. That's going to take time. Or you might have that fan board, and the fan board might be not fully occluded, but it's surrounded by a bunch of other stuff. Trying to select things that are hard to select is an interesting problem in VR, and there's lots of cool solutions. And in this case, having proxies right there and sticking around can be really useful. So let me show you an example of that in action. So these are now permanent proxies. When you let go, the halo is going to disappear, but the proxy sticks around. Here we are making a proxy of RAM and not grabbed anymore. Here's a proxy of a CPU. It's permanent. It's going to stick around. And now if we were to grab again the motherboard, grab again the RAM, and now we can place the RAM on the motherboard. And for the actual objects, you're seeing that take place off in the distance. And that red over there indicates that in this user study, you're supposed to next put the CPU in place. So temporary versus permanent, we did a study to try to see if we could show some advantages for permanent over temporary, where again, lots of advantages when things are specifically hard to be able to go and acquire. So if it's hard to acquire the first time, maybe we can make it a lot easier to acquire the next time you want to do something with it. And so we did a user study. We had hypotheses that in our study, participants would perform faster with permanent rather than temporary proxies for hard tasks, and that they would prefer permanent over temporary proxies. And so we had two different kinds of proxies, again, permanent and temporary. Two kinds of tasks, what we call hard and easy. The hard ones, we had to select objects, or the user had to select objects that had a very small projection, were occluded, were far away. The easy ones were ones that had big projections or were close. So this is the within-subject experiment. Each participant did both of these kinds of tasks and both of these kinds of task difficulties. We had a block of permanent proxies, a block of temporary ones. They were counterbalanced in order, so we didn't always have temporary before permanent. We had both practice and timed trials for easy, and then practice and timed for hard. And to cut to the chase, it ended up with our particular job mix that the mean step completion, and here we're showing little violin plots of the distribution, was faster for the hard trials in permanent proxies than in temporary ones. It turned out it was also a little bit faster, both significant, for easy trials. We asked people what they preferred in the study. We kind of cheated in the sense that we made a lot of things really hard, for which we really assumed that permanent proxies would be easier, and all the participants preferred permanent over temporary. But again, this is really a function of task mix. In a world in which permanent proxies create clutter, and you have to spend your time getting rid of them, you could easily make a job mix in which you'd be surrounded by so many proxies and you have to get rid of them, and it would take a lot of time. But in this case, we did what's called an unweighted NASA TLX, and this kind of a subjective study of load indicated that for all the different metrics that we were looking at, mental demand and physical demand and performance and effort and frustration, but not, interestingly, temporal demand, people actually preferred, or rather thought, that there was less load in the case of the permanent proxies. So conclusions, proxies can represent virtual objects, real objects. They can be used to refer to them, to show things to do, or to actually manipulate them. Temporary, you avoid clutter, which is maybe the main reason behind what was happening in that original version of that bimanual proxy technique. Permanent means it's really easy. You can be made really easy if you leave them in good places to reselect them to use them again in tasks in which you have to continually reuse something. And so in general, proxies make it easier and faster to select and manipulate objects that project small because they're far away or because they're very small themselves. They're occluded potentially by other stuff. They may be surrounded by others, making them harder to select unambiguously. They might be moving, which makes them really hard to select. So once they've been selected, the proxy then just sits there, literally a sitting duck for you to manipulate. They might be hard to see for lots of other reasons that things might be hard to see. So at this point, I'm going to stop, acknowledge the funding sources for the work that I just showed you, point you at a poster that we presented earlier this year at IEEE VR, and hopefully I have a few minutes for questions. Thank you. Any questions? Yes?
This is obviously very interesting for training.
Mm-hmm.
Using XR, but what do you envision could be other uses?
Okay, so training, I think, is clearly important for demonstrating stuff. If you're simply building something yourself, right, and you're doing it virtually, and you have a bunch of stuff that is arrayed around you, okay? I often, when I work with physical things, I lose stuff. I misplace them. I don't remember where something was. And so to be able to have another copy of it in a nice organized arrangement, which I made myself. Here's a proxy of that thing over there, it's over here. A proxy of that thing over there, it's over here. I can now very quickly grab that one, and now I'm working at it with a proxy, or grab another one, and now I'm working at that one with a proxy. And so in that original technique, the original paper that was done by Pierce and colleagues, they weren't really thinking of training, they were thinking of people building stuff. And the idea was by having the proxies, I can now, for something that might be involving pieces that are be far away from me, instead of having me travel over to where they are and work with them, and maybe the pieces are dispersed around the environment, I can grab a proxy of that one, grab a proxy of this one, and then I can manipulate them. Two-handed manipulation is something we do all the time in real life, and now we can do it virtually really easily. When I've created the arrangement that I want, I let go, and it's now arranged where we want it to be remotely. And because that non-preferred hand proxy, the real beauty of the original technique, you can wave it around as much as you want to while you're manipulating it. It does not affect the non-preferred hand proxy's object. It just sits there. So if you're trying to put that little beefeater hat on top of the soldier and it was sitting next to them, rather than having to walk over and do it, you can grab the soldier, you can easily, put the hat on like this, and yet you're not turning the soldier on its side. Okay, the soldier just stays upright. So actually manipulating a physical world, or in this case a virtual world, remotely, is one very good example, no training necessarily implied. Yes?
Hey, so do you take it back out to the real world? In other words, do this manipulation of VR, it doesn't weigh anything, do anything you want. When you're done, does that translate back to the real world effect?
Okay, so if we had robotics to do that, it would. But in what I showed you with the gears and stuff, the robot, who isn't really a robot, is the technician. And they don't know what to do. Instead of being shown, demonstrated, okay? And they better do it. And because the remote expert can see what they're doing, they can say, no, not that gear. And there's, audio communication between the two people. That was a demo that we did at SIGGRAPH, and you could see those little red and yellow lines. Both of the people there in the demo were just members of the attendee audience. And so the expert wasn't going to be an expert. We had to show them what to do in turn so they could look like they knew what they were doing. And they therefore had that little red line or yellow line showing them what to do. Yes?
Yeah, I got a question. I want to hear more about the usage of physical properties to manipulate virtual objects. Does having these sort of physical elements make it easier to understand the interactions that are happening in the virtual world?
Okay, and so in virtual world or in physical world?
A physical object to interact with something in the virtual world.
Okay, so what we were using were virtual copies of things to show the person who's going to be manipulating the physical stuff what we want them to do. So they were seeing in the case of the technician, you could see that gear moving into place, and they were being talked to as well also by the expert at the same time, and the expert is saying, yeah, grab that gear over there and put it on this axle over here, and then, you know, they can see it being done. So if they see the technician doing the wrong thing, they can say, no, stop, or do it more slowly, or notice how slowly I'm doing it. If you do this really fast, you might break it, and this is a really expensive part. Slow down, don't go any faster than I'm going.
Okay, thank you so much.
You're welcome.
Give him a round of applause, please. Thank you.